Let's start with few problems. Let's look at the first one. See, find the area of the region bounded by the two parabolas y is equal to x square and y square is equal to x. Now, to solve all the problems, like I've told you before also in solving those problems, always draw the graph. Draw the graph, shade the area what is required, and then find the points, and then finally you have to apply the formula and get the area. Clear? Never start with the formula, always start with the figure. Now, finding the area, so let's plot the graph first. Now, first thing what we have, the x and y axis. Alright. First, let's start with y is equal to x square or x square is equal to y. Up opening parabola, isn't it? So, we have this. Now, this is x square is equal to y or y is equal to x square. Well and good. The next one is y square is equal to x. So, y square is equal to x is going to be something like this. This is y square is equal to x. Now, the required area is going to be this one. See this area, small area. This is what we are looking at. Now, we have to find the points of intersection. One is obviously the origin, correct? The next one is this point. Let's call this point as A. Now, we need to find the value of A. For that, let's solve the two equations. Fair enough? See what you have, y is equal to x square, isn't it? Substitute that in this equation. That means what we have here is that instead of y, in this case, we substitute x square. So we get x square whole square is equal to x, or x power 4 is equal to x. So we can write two ways we can write. One, you can cancel the x and x, isn't it? So if you cancel the x and x, we'll get x cube is equal to 1. That means x value has to be 1. There is no minus, isn't it? That means the point what we have is 1, comma, don't you think it has to be 1? Because when x is 1, if you substitute in any one of the equations, it has to give you 1. Do not take the minus 1. Again, I'm telling you. The reason is it's in the first quadrant. So both x and y has to be positive. So there is no negative whatsoever. It has to be 1, comma 1. Well and good. Now we need to figure out which area to take, because the formula is what? The formula is f of x minus g of x dx. Integral from a to b. Correct? This is the formula. Now, which one do we take it as f of x? Which one do we take it as g of x? For that, from a, first you draw a perpendicular like this. Okay, now of the two, see, you see blue color graph and black color graph, correct? Now, between the blue and black, which is the above one, the blue one is the above one. So that becomes f of x. This is how you understand which area minus which area. From this region to this region, or from this point to this point, which is the above graph, which is the below graph, that minus this. Fair enough? That means in this particular case, we have to do integration from 0 to 1. Correct? F of x becomes the blue color one. That means f of x becomes root of x minus g of x becomes x square dx. Fair enough? So we are going to get integral of, or once you integrate, I think it's much easier to just integrate x power half, right? When you integrate that, x to the power of half, 1 by 2 plus 1. 1 by 2 plus 1 becomes 3 by 2. X to the power of 3 by 2 divided by 3 by 2, or you can write this as 2 by 3. Fair enough? Minus x cube by 3 from 0 to 1. So if you substitute 2 by 3 into 1, 1 minus 0, minus 1 by 3 into 1, which gives us 2 by 3 minus 1 by 3. So the final answer is going to become 1 by 3 square units. This is going to be the final answer. That means the area, the enclosed area is 1 by 3 square units. And this is how you do the first one. Now let's do the next one. The second one. Find the area of the circle this, which is interior of the parabola x square is equal to 4y. All right. Now we have a circle and a parabola. Correct? Again, what is the first step? Drawing the figure. So we'll start by taking the figure. For that, let's, change the equation of the circle. We say change the equation, just rewriting it in a different form. Okay, so your 4x square plus 4y square is equal to 9, correct? Let's make it as x square plus y square is equal to 9 by 4, or x square plus y square is equal to 3 by 2 whole square. Because this is in a standard form, isn't it? X square plus y square is equal to a square. This is in a standard form. So now we can write a circle. So first what we'll do, we'll write a circle, something like this. Next we need to write a parabola. X square is equal to 4y. X square, up opening. So we have to write x square is equal to 4y, something like this. Alright. Now look at the question. The question says, find the area of the circle which is interior of the parabola. That means this entire region, isn't it? This entire region. For that, what we can do or what we have to do is that do not take the whole thing. Instead, we'll take one part of it and we double it. In the sense, what we'll do is we'll take, this is one point, obviously, and we'll take this point. In the sense, what we are doing is we are finding this area. See, this area we are finding, double it. So that's going to give us the total area. Make sense? So this is what we are going to do now. Okay. So then what is the second step after writing the figure? Finding the points of intersection. Correct? So let's substitute here. Now what do we have? The equation is what? X square plus y square is equal to 9 by 4. Correct? But x square is nothing but 4y. 4y plus y square is equal to 9 by 4. Or y square plus 4y minus 9 by 4 is equal to 0. Now if you want, you can multiply the entire thing by 4. It's going to make things a lot more easier, that's all. 4y square plus 16y minus 9 is equal to 0. Now splitting the middle term, 4 into 9 is 36, and 36 we need to split to get a value of 16, 18 and 2. So we'll get 4y square plus 18y minus 2y minus 9 is equal to 0. Okay. Now if you want, you can take 4y square and minus 2y. So you can take 2y common. 2y into 2y minus 1. Next minus 9 into 2y minus 1. Sorry, take plus 9 common. Plus 9 into 2y minus 1. So 2y minus 1 into 2y plus 9 is equal to 0. So what do you get? Y value is half, or y value is minus 9 by 2. When y value is half, so it's going to be a positive value. That means both the sides, you're going to take y value as half. Since y value is half, then what we'll do, we'll substitute that over here. X square is equal to 4 into y value is half, 4 into half, 2. So x square is 2, x is plus or minus root 2. So now what are the points? Root 2 comma half minus root 2 comma half. Now we have the points. First, draw the graph. Second, plot the points. Okay. After finding the points, then what is the third step? Now you have to understand which area minus which area. Again, for that what we'll do, like I told, from the point, draw a line like this, which is the above curve. Circle, correct? Circle is above, parabola is below. So we do circle minus parabola. That means what we are doing here, we are doing circle minus parabola, root of this one. So we have to take this one and we have to take this one. Okay, now let's do that one. And once we subtract it, then we can figure out. Remember, we are doing from 0 to only till the positive side, 0 to root 2. Then we are doubling it. Clear? So let's do this one now. So we have area integral from 0 to root 2. First is the circle. But remember, for the circle part, we have, or okay, maybe we can do it something like this. Area of circle minus area of parabola. Parabola. Okay. Now for the circle, we need y dx, correct? So for this one, you see, you have 4x square plus 4y square is equal to 9. Now we'll start by taking y square is equal to 9 minus 4x square whole thing by 4, or y is equal to 1 by 2 into root of 9 minus 4x square. Correct? Next, the area of the parabola. So for the parabola, we need just y value. Correct? And y value is going to be x square divided by 4. This is for the area of parabola. Now, when you put it under the integral sign, a value is 0 to root 2, 1 by 2 to root of 9 minus 4x square minus 1 by 4 into x square dx. We'll split the integral, much more easier to solve. So when we split the integral, so we'll get a is equal to half integral 0 to root 2 root of 9 minus 4x square minus 1/4 integral of x square 0 to root 2. Fair enough? Now, the first part, root of a square minus x square formula, correct? Let's apply that one now. What is root of a square minus x square? We have x by 2 into root of a square minus x square plus a square by 2 sine inverse of x by a, correct? Let's substitute that here. But a small change will have to do because we have 4x square, right? Maybe you can take it, let 4x square or 2x as t. You can do it that way. Or if you know it directly, you're welcome to do it that way also. Okay, both the ways are fine. Since we have 4x square, what I'll do, I'll just substitute that let 2x is equal to t. So 2 dx is equal to dt, or dx is equal to half dt. So we'll substitute that. In the sense, we'll make this as half integral 0 to, of course, the root 2 is going to change. But what we'll do is, at the end, I'm going to substitute that x back. Okay? Root of 9 minus t square into half dt minus 1/4 x square dx from 0 to root 2. Again, I'm telling you, I am not changing the limits right away. The reason is, after the integral sign, I'm going to put that x back. I'm not going to keep in terms of t. That's why I'm not changing the limits. Fair enough? So here, half into, so half into half becomes 1 by 4. Okay, so here what we are going to do, so let's make this as 1 by 4. 1 by 4 x by 2 t by 2 into root of 9 minus t square plus a square, which is 9 by 2 into sine inverse of x divided by a. Okay, minus, so this is for 1/4. Again, I'll put it back. I'll take the t as 2x. I'm going to substitute it back. Minus 1/4 of x cube divided by 3 from 0 to root 2. Now if you substitute back 1 by 4, 2x divided by 2 into root of 9 minus 4x square plus 9 by 2 sine inverse of 2x by 3. Now we can take 0 to root 2 minus 1 by 12 x cube from 0 to root 2. Now we need to substitute. Now here 2 and 2 cancels. You get 1 by 4 into, substitute root 2. Root 2 into root of 9 minus 4 into 2, which is 8, plus 9 by 2 sine inverse of 2 root 2 by 3. Okay, next if you substitute 0, everything becomes 0. Because see here, very simple. When you put x as 0, this is going to become 0. So the entire term becomes 0. Then if you take this as 0, sine inverse of 0 is 0. So everything becomes 0. That's why everything becomes 0. Then minus 1 by 12 of root 2 whole cube. So 1/4 of root 2 plus 9 by 2 sine inverse of 2 root 2 by 3 minus 2 root 2 divided by 12. I think there is not much you can do about it here unless you take an LCM and you can do it. Okay, so maybe if you take LCM, you get root 2 by 4 minus 2 root 2 by 12 plus 9 by 8 sine inverse 2 root 2 by 3. The only simplification what we can do here is we can take 12 as the LCM. Then this is going to become 3 root 2 minus 2 root 2 divided by 12. Or the final answer is going to become root 2 by 12. Okay, so the final answer becomes root 2 by 12 plus 9 by 8 sine inverse 2 root 2 by 3. So many square units. Okay, this is the answer for the second question. Now in the next video, we'll solve few more questions. Let's solve the next problem. See here, find the area of the region bounded by the curves 1, 2, 3. There are 4 curves here. Let's draw the curves carefully and understand what area we are looking at. Okay, so first let's draw the x and y axis. Alright, see the first curve is y is equal to x square plus 2. X square, so it's up opening. Since you have x square plus 2, the graph is going to be something like this. Okay, assume it's going to be something like that. Then we have y is equal to x. Now y is equal to x is a line, 45-degree line, slope of 1, correct? Then x is equal to 0, that's the y axis, and x is equal to 3. Okay, so x is equal to 3, it's going to be somewhere something like this. So the area what we are looking at is this one. See this area, that small area. That's the area what we are looking at. Now in this case, what we need to do, it's very simple. See here, the area under the parabola minus area under the straight line, correct? So if you do this, you are going to get the proper area, whatever we are looking at. All right. The points, actually, already know the point. Don't you think so? Because this point is 0, this point is 3. X is equal to 3, they've already given to you. Just use the formula f of x minus g of x from 0 to 3. Very simple. Okay. So here, that means first what do we have? The area is integral from 0 to 3. The area of parabola minus area of the line. Area of the line in the sense area under the line. I think that particular word makes more sense rather than saying area of the line. Area under the line. All right. So area of the parabola is going to be integral 0 to 3. Y value, right? X square plus 2 minus the next value is x. Y is equal to x, right? So that's all. Now, if you integrate this, you'll get x cubed by 3 plus 2x minus x square divided by 2 from 0 to 3. Now, 3 cube 27 by 3 plus 2 into 3 is 6 minus 9 divided by 2. So 3 into 9, 9 plus 6, this is going to be 15. 15 minus 9 by 2, which is going to give us 21 by 2. So the final answer is 21 by 2 square units. This is going to be the final answer. Okay, so this is the answer for the third one. It's just a continuation. All right, let's do the next one now. Let's do the fourth one. See this particular question. Find the area bounded by curves this and this. Now, if you carefully look at the question, both of them are circles. The second one, it's very obvious. The first one, it's a little bit, you can say that the circle has been moved towards one of the sides. First, let's draw the figure. So here, first what you have is the x and y axis. The first curve, x square plus y square is equal to 1. This is going to be the first curve. So this is x square plus y square is equal to 1. Now you have x minus 1 whole square plus y square is 1. In the sense, the center is going to be here. So here you can say that you're going to have a circle, something like this. Okay. Now what we are looking at is we are looking at this entire thing as the area. All right. For this, what we'll do, we'll have to split this. Okay, because when you are splitting this, we'll have to take from here to here. We have to split it. Okay, so this is one area and the remaining is one more area. So we are looking at two areas. Once we understand that, okay, this has been split into two parts, finding the points of intersection is the next case, isn't it? This is the first, second. So we have 2 points where the two circles are intersecting. We need to find these 2 points. We need to find both x as well as the y value, correct? Now here, let's substitute and figure it out. Okay, now one thing is very obvious that the x value is going to be somewhere close to half, midpoint. Don't you think so? Somewhere close to it. Y value is the one what we have to look at it. Okay, even though x value is enough for us, still y value also you have to calculate. Okay. Okay, now the second equation what we have is here x minus 1 whole square plus y square is equal to 1. Now subtract both the terms, both the equations. If you subtract, then you'll get x square minus of x minus 1 whole square is 0. Y square and 1 gets cancelled. X square minus of x square minus 2x plus 1 is 0. So you get 2x is equal to 1. So x is equal to half. So we got the point this as half comma something. I think if you know the value of x, that's good enough because we are doing y dx, right? So the limits are going to be 0 to half, correct? What we get now is that, so we'll do one thing. Let's split this one. Okay, let's split it. In the sense, first what we'll do, we'll take from 0 to half. And if you look at this, there are two curves here. So as in two parts. See, the top is one part, bottom is one more part. That means here we have to do 2 times, correct? So first what we'll do 2 times twice. So the area whatever we are looking at. So let's call this point as A, let's call this as B, let's call this as C, let's call this as D. So what we are doing 2 times the area of O A B O. See, O A B O, that gives us the upper area. Twice of that is going to give us the of area of O A C O, correct? O A C O. That's going to give us the entire, that one part of it. This is one part what we have to calculate. Now, along with that, plus, which is the next part we have to take, 2 times area of A B D A. See, A B D A. A B D A is basically this part, correct? A B D A. So if you do 2 times of that, that's going to give us area of A D C A, which is the right side part of it. So we have left side, we have right side. A very important part what you guys have to understand is that when you are trying to calculate the left part of it, you know, the one which has been shaded in gray, that part when you're calculating, the limits are from 0 to half, correct? But when we are calculating on the right side, then we'll have to take from half to 1. Now, the second step of solving a problem is done. First step is drawing the figure. Second is finding the points. That is done. Now, the third part of it is which curve to take and what limits to apply. Correct? 3 parts. So, for the third part, what we are looking at is that which curve do we take? From 0 to half, which curve do we take? From half to 1, which curve do we take? Correct? This is the part. Now, when you look at the left side part of it, which curve are we looking at? Are you looking at the blue colored one or the black colored one? The blue one, isn't it? Because the blue colored graph is the one which encompasses that particular area, correct? And on the right side, if you look at it, the black colored graph, that is the one which is going to encompass that particular area. In the sense, for the first part, that is for calculating this area, we have to consider this graph or this particular equation. And for the second one, that is finding this area, we need to calculate this particular graph or the curve. I hope this is clear. And I also am hoping that you guys have understood why we are taking that particular graph. Okay, again, I'll explain why we are taking that. Because if you look at the graph or if you look at this particular combination of the two graphs, the left side graph, the area is encompassed by the equation x minus 1 whole square plus y square is 1, the blue colored one. But if you look at the other part, the right side part of it, there the area is encompassed by the first graph, that is x square plus y square is equal to 1. This is the reason why we are taking these two graphs, and I hope all of you are clear that why we are taking 2 times the area and trying to calculate. Yeah. So now Let's do the math. Now that you know which graph to take, what are the limits, and you have also calculated the point. So this is the entire part. Now comes the math, the actual calculation part. All right, so let's do the math part now. First part, what we have is we'll do integral from 0 to half. Remember, two times 0 to half. And in this case, remember, we are taking this particular graph, correct? Since we are taking this graph, we have to do root of 1 minus of x minus 1 whole square, correct? This one plus half to 1 root of 1 minus x square dx. See, this is the overall part. Now we have to solve this one. We have to use the formula, substitute the equation, substitute the values, solve the equation and get the answer. Okay, let's do the math. So we are here, we have 2 times twice of root of a square minus x square. So x by 2 into root of a square minus x square plus a square by 2 sine inverse of x minus 1 from 0 to half plus x by 2 root of 1 minus x square plus 1 by 2 sine inverse of x from half to 1. This is the next part. Okay. Now here you have 2 times. If you substitute half minus 1, half minus 1 is minus half by 2 minus 1 by 4 into root of 1 minus half minus 1. Half minus 1 is minus half square is 1/4 plus 1 by 2 into sine inverse of half minus 1 is minus half. Next, minus of, now remember we are applying this limit, lower limit as 0. So when you're applying the lower limit, 0 minus 1 is minus half into root of 1, which is 1 itself, plus half into sine inverse of minus 1. This is just the first part. We are not solving the second part yet. Okay, we'll come to the second part. So now after this, what we are looking at, 2 times minus 1 by 4 into root of 3 by 4 plus half into sine inverse of minus 1 by 2 becomes minus pi by 6 minus of minus half plus half into minus pi by 2. This is what we have, correct? So now after this, we have to solve this a little more. Okay. Now when you solve this one, this we have to further solve. All right. Now what we'll do, we'll come to the next part, the second part of it. So if you do the second part, here we are substituting 1.5. Correct? So let's do this one now. Is you're going to have x by 2 into root of 1 minus x square plus 1 by 2 into sine inverse of x from half to 1. Correct? So if you substitute here 1 minus 1, so this is going to become 0. So half sine inverse 1 minus of half by 2 is 1 by 4. 1 minus 1 by 4 plus half sine inverse 1 by 2. So half into pi by 2 minus 1/4 of root 3 by 4 minus 1 by 2 into pi by 6. Now the final part is what? See, you have the previous case and you have this one, correct? Now if you look at it, that 1/4 into root of 3 by 4, this will get cancelled. Likewise, certain parts they are going to get cancelled, correct? So the final answer, 2 pi by 3 minus root 3 by 2. This is going to be the final area. Okay, so many square units. This is going to be the final answer. In the sense, the area, okay, the area between the two circles is going to be this one. Fair enough? So these are certain type of standard problems what you can expect from this particular chapter.